Good day, I am Brian Dave Gasok and it's nice to see you in this video again. So for today's video, we will have another tutorial regarding linear programming, how to solve linear programming specifically using graphical method. So now, join me and let's start. Okay, now let's discuss linear programming. So today's video, we will talk about linear programming, specifically how to solve linear programming using graphical method. So first, let's answer this question. What is linear programming? Linear programming is a mathematical modeling technique in which a linear function is maximized or minimized when subjected to various constraints. This technique has been useful for guiding quantitative decisions in business planning, in industrial engineering, and to a lesser extent in the social and physical sciences. We have here fact or frequently asked questions. So first question, what are linear programming used for? So linear programming is used for analyzing the supplies in the manufacturing industries. It is used for shelf space optimization. Linear programming is also used for optimizing daily routes. It is used in machine learning. Next question we have, what is the use of graphical method? A graphical method of linear programming is used for solving the problems by finding out the maximum or minimum point of the intersection between the objective function line and the visible region on a graph. Next question, what are graphical methods? So graph is a powerful tool for data evaluation as they provide us with quick and visual summaries of essential data characteristics. Examples of graphs can be a box plot or a histogram. So graphical methods are basically used for qualitative statistical evaluations. Now, for solving linear programming problems graphically, we must consider these things. So we have variables, objective function, inequality constraints, and non-negativity constraints. These four are needed in order for us to solve linear programming problem using graphical method. The graphical method of solving linear programming problems is based on a well-defined set of logical steps. With the help of these steps, we can master the graphical solution of linear programming problems. So, linear programming graphical method. To find the graphical solution of linear programming problems, we have to follow a few steps. So we have 7 steps to follow in order for us to answer linear programming problems. First is step 1. Formulate the problem using the objective and the constraints. Step 2. Frame the graph by plotting the constraints lines. Step 3. In this step, determine the valid side of each constraint line. Step 4. Our next task would be to identify the visible region. Step 5. Find the most suitable optimum point. Step 6. Determine the optimal solution algebraically by calculating the coordinates of the optimum point. The last one is the step 7. The final step would be to determine the value of the objective function. Now, we have here an example. So, Reliado Furniture Company produces wooden desks and chairs. The unit profit for desks is $6, whereas for chairs is $8. The only two resources that the company uses to manufacture desks and chairs are the woods in board feet and labor in hours. On an approximation, it will take 30 board feet and 5 hours to complete a desk, and 20 board feet and 10 hours to complete a chair. The company has 300 board feet of wood and 110 hours of labor available. How much of each type should be made to maximize the profit of the company. The objective function of the company is to maximize profit, and the decision variables are the resources that are the goods and the labors. So the constraint set can be the limitations on resource availability, which is 300 board feet of wood and 110 hours of labor. So using LP problem graphical method, the management can come to a decision on how to allocate the limited resources to maximize profits. So the best way to answer easily the problem is to put all the data given in the problem into a table, which then be analyzed accordingly. So see the table below. So as you can see here, the table, we have put all the data given in the problem. So we have the resources, the goods, and the labor. Sorry, that's labor. And the desk and chair, which are represented by variable X and variable Y. So we have here the availability and the profit gained in the desk and the chair. So now, let's proceed to the step 1 in answering it, to formulate the problem using the objective and the constraint. As you can see in the given table, we have the variable X and Y, which represents the number of desks and number of chairs. So we have here the objective function. We have the objective function is to maximize Z is equal to 6X plus 8Y. We have here subject to inequality constraints. The inequality constraints is the goods available. We have here 30x plus 20y less than or equal to 300. And the labor in hour available is 5x plus 10y is less than or equal to 110. And the last is the non-negativity constraints. We have x and y are greater than or equal to 0. This is the restriction. Now let's proceed to the step 2. So the step 2, we have here the first constraint. We have 30x plus 20y less than or equal to 300. So our goal here is to find the value of x and the y so that we can put it into the graph. So to find the value of x, we have to let y is equal to 0. So we have here 30x plus 20y less than or equal to 300. So 30x plus 20 times 0, since we let 0 is a value of y. So less than or equal to 300. So since 20 times 0 is equal to 0, so the remaining is 30x less than or equal to 300. So to find the value of x, we have to divide both sides by 30. So we have the remaining x. We have the remaining x less than or equal to 300 divided by 30 is equal to 10. So next, we have to let x is equal to 0. So 30x plus 20y is less than or equal to 300. So 30 times 0, since we let x is equal to 0, plus 20y less than or equal to 300. So we have the remaining 20y less than or equal to 300. So to get the value of y, we have to divide both sides by 20. So we have here y is less than or equal to 300 divided by 20 is equal to 15. So we have now the graph like this. The other constraint are inequality constraint. We have 5x plus 10y is less than or equal to 110. So the same process from the first constraint, we have to let y is equal to 0 so that we find the value of x. So 5x plus 10 times 0 less than or equal to 110. The remaining is 5x less than or equal to 110. Divide both sides by 5 so that we can have this x less than or equal to 22. So we have to let x be equal to 0. So 5 times 0 plus 10y is less than or equal to 110. So 10y less than or equal to 110, divide both sides by 10 so that we can have this y less than or equal to 11. So we are going to put it in a graph. So the graph looks like this. So we put a line to connect those two given point. So the step 3 is to determine the valid side of each constraint line. So now we are we put the two lines connecting the two constraints so that to get the points, so maximum points as well. So the graph represents the step 3. We have here the step 4. So the step 4 is to identify the feasible region. So here is the feasible region, wherein the feasible region is the region of the graph containing all the points that satisfy all the inequalities in a system. So therefore we put a shaded region, which is the feasible region, here, in which it contains all the points, so satisfies all the inequalities that are given in the constraints. So now let's proceed to step 5, in which to find the most suitable optimum point. So we have here two given constraints, the 30x plus 20y less than or equal to 300 and 5x plus 10y less than or equal to 110. So in the given graph, we found the feasible region in this area, in which we have these 4 points, the 0, 0, which is the origin, the 0, 11, the 10, 0, and we have here the unknown point. So we have to solve the x, the value of x and the y. So in order for us to do that, we need to use this two constraint. So in order to find the value of y, we have to make sure that the value of x in these two constraints will be cancelled out or will be equal to 0. So we use the second constraint, 5x plus 10y less than or equal to 110 multiplied to -6, so that we can have this value of -30x minus 60y less than or equal to -660. So let's solve this. So we add the two constraints, the -30x minus 60y less than or equal to -660 plus 30x plus 20y less than or equal to 300. And now we got this result as, since -30x plus 30x is equal to 0, so we have the remaining number of -60y plus 20y is equal to -40y less than or equal to -360. So to find the value of y, we have to divide both sides by -40, so that we can get this value of y is greater than or equal to 9. So when you're confused why is it the inequality is being reversed into greater than sign, because when we are going to divide both sides by negative number, so the inequality constraint will be reversed. Okay, so that's why. Next, we will use the 30x plus 20y less than or equal to 300 constraints, so that we can find the value of x. So we have to substitute the value of y, which is equal to 9. So 30x plus 20 times 9 is less than or equal to 300, which we are given here the 30x plus 180 less than or equal to 300. So by using addition property of inequality, we have here 30x less than or equal to 300 minus 180, because we add both sides by negative 180. So we get 30x less than or equal to 120. Divide both sides by 30 so that we can have this x is less than or equal to 4. So now we found the the value of x and y of this point. Okay, let's proceed to step 6, which is to determine the optimal solution algebraically by calculating the coordinates of the optimum point. So since we found the value of x and y in the unknown point, so as you can see, we have given here 4 points. So we have the point 0, 0, point 0, 11, point 49, and point 10, 0. So we have to solve for this point. So point 0, 0, we have z, substitute the value of x and y. So z is equal to 6 times 0 plus 8 times 0 is equal to 0. So next is the point 0, 11. So z is equal to 6 times 0 plus 8 times 11 is equal to 88. Next is the point 4, 9. So the z is equal to 6 times 4 plus 8 times 9. We have 96. Last is p 10, 0. So we have here z is equal to 6 times 10 plus 8 times 0 is equal to 60. So as you observe, we have the maximum number or the biggest number here in this points. We have reached it in the 0.49, which is we gained the value of 96. So the step 7, the last step, is the final step would be to determine the value of the objective function. So the value of the objective function is the z is equal to $6 times 4 plus $8 times 9 is equal to $96. Therefore, the conclusion, by making 4 desks and 9 chairs, the company can gain the maximum profit of $96. So we just solved the problem using graphical method. With that, thank you for watching and hope you learned something in this video. See you again next time. This is Brian Dave Gasok saying goodbye and God bless everyone. Don't forget to like, share, and subscribe. Thank you everyone.